In this lesson, we'll tackle the presentation layer. It goes by other names like the user interface layer or the UI layer, perhaps others. The role of the presentation layer is simple. It should have just enough logic to know which methods to call on the domain layer, or more likely the application services layer, to retrieve the data it needs for display or data it needs to supply to the domain layer to add, update, or delete data or perform some change of the application state and so forth. It should have enough logic to format the data for display. Preferably, the formatting would be simple in nature, formatting dates and currencies correctly for a given culture setting and things of that sort. Anything required more advanced business logic for formatting should happen on the business logic layer or the domain layer. It should have enough logic to perform simple validation on the data that the user enters into the application using forms or whatever the case might be. So required fields, ranges, data types, formats, things of that nature. Anything requiring more business or domain logic validation should clearly happen on the domain layer. The presentation layer should also report exceptions to the user that the business logic layer or the domain layer can't absorb, or rather can't resolve on its own, and may require a decision or some input from the end user. Your best strategy is to keep the lines delineating the presentation layer and your application services or domain layer as clean as possible. This gives the majority of your application source code. In other words, it gives the code in all the other layers the longest shelf life possible. So in the previous lesson, we said that there's not a lot of complexity in the presentation layer. I said that to make a point that the heart of the complexity in any system is in the domain problem. However, that's not to say that there aren't unique challenges in the presentation layer. For example, you have to pay attention to usability issues because, after all, it's the layer that the end user will interact with. However, I don't see these as architectural issues. These are user experience or usability issues that require an entirely different set of skills. So we're not going to be talking about end user experience design in this series. I'll be referencing the Microsoft Application Architecture Guide. If you look at page number 68, in that guide, it gives you the diagram and is highlighting the presentation layer. You can see that it displays two types of components that you commonly see in the presentation layer, namely user interface components and presentation logic components, or UI process components. Now, hopefully the term user interface component is something you're familiar with. Even if you've come directly from the C# Fundamental series, you're probably aware of the toolbox in Visual Studio and the ability to drag and drop controls from the toolbox to a design surface, whether that's Windows Forms, Windows Presentation Foundation, an ASP.NET Web Forms application, and so on. So you're grabbing and pulling text boxes, drop-down list boxes, buttons, grids, and the like from the toolbox onto the designer surface. And those are all examples of user interface components. The presentation logic or UI process components are more structural or behind the scenes. These provide a mechanism for data, once it's been retrieved from the domain layer, to be prepared and translated for presentation and vice versa. So in ASP.NET Web Forms, there's a code behind file, which is a partial class that works together with the ASPX file that contains a series of event handlers. In an event like form load, developers write presentation logic necessary to retrieve collections of data from the application services layer, which in turn retrieves the correct data from the domain layer, and then sets the data context of individual user interface components so that they bind to data for display, rather either empirically by wiring it up in C# or declaratively by setting properties that know how to go into and retrieve the appropriate data by using the properties panel or something along those lines. In an ASP.NET MVC application, there are controllers which contain a series of action methods. Inside of those action methods, developers write presentation logic to retrieve collections of data from the domain layer or the application services layer, and then they write presentation logic to put that data into a view model, which is an intermediary object that spans both the view and the controller and kind of talks between the two. The view references attributes of classes in the view model then for display. Now, in both cases, we see a further delineation of responsibilities and concerns required to retrieve data and display data to the end user. And that's basically the point that this section in the Microsoft Application Architecture Guide is making. And just as it's important for each of the primary layers to keep their concerns separated, sub-concerns like presentation logic, the view model, the view, and so forth should maintain their separation as well, if for no other reason than to keep their implementation clean. As a developer, it's useful to know where things belong conceptually so that you can name things correctly, so that you can keep responsibilities delegated correctly to the proper code implemented in the right places. All right, so let's talk about the technologies that are available in the .NET world that map to the presentation layer and why you would want to choose one of those technologies over another. Before I do, let me give you this admonition. Since the presentation layer technologies change often, there's been probably over a dozen since I've been a Microsoft developer, it's important to stay flexible and to know that this might be one area of your application that's most prone to change due to the emergence of newer technologies. While there are probably a dozen different Visual Studio project templates and APIs that you could choose from, I really only recommend two, maybe a third one if you only need a simple CRUD style application like we talked about in the previous lesson. I personally prefer web technologies over desktop technologies, or what the guide calls rich client applications. Or I prefer web technologies over vendor-specific mobile APIs if I can get away with it. I would categorize both desktop or rich client applications as well as vendor-specific mobile APIs as this umbrella term, native client applications. So I generally prefer web technologies over native client applications. In other words, you're writing applications that are not designed or not interpreted by a web browser. They are designed to be used on a specific operating system, whether that's a desktop operating system like Windows 7, Windows 8, or the Mac OS X, or a mobile operating system like Windows Phone, Android, or iOS. Now, there's quite a debate that goes on as people are grasping whether to utilize a web client or a native client for their given project or idea. Now, when the decision is purely up to me, this is the litmus test that I use. First of all, if I'm building a forms over data application, hands down, I would prefer a web stack of technologies. Today, that stack would include ASP.NET MVC, HTML5, CSS3, JavaScript, jQuery, and a bunch of other little libraries as well, depending on what the task was. I try to utilize some responsive CSS3 framework like Bootstrap by Twitter and perhaps some other libraries as necessary, but I generally like to keep the complexity low and enable the largest target number of potential browser vendors and devices. I would include dynamic functionality on the client sparingly, which seems to be the opposite of trend nowadays, where a lot of people are writing a lot of JavaScript on the client. I'm of the opinion that those who are building these newfangled wild user interfaces filled with lots of JavaScript don't seem to have to worry about accessibility and such. Maybe that's a overcharacterization, but I tend to like to keep things simple on the client. It also, for example, and here's where I have to come out of the closet a little bit and say that I use an iPhone. I don't use a Windows Phone. One of my biggest annoyances with using the Windows Phone is when I go to a website and like ESPN, for example, I'll be reading the comments, and because of the way they've implemented the JavaScript that dynamically pulls in the new comments every 2 or 3 seconds, it'll jump and I'll be reading something and it'll jump up higher in the screen. Now I've got to scroll and find what I was reading. And so many times what I found is that when dynamically pulling data from some sort of web service into my application using JavaScript and Ajax, that the user experience on mobile devices is very poor, and so that's why I'm generally against it. If they want to refresh data, let them go back and grab the page fresh from the web server. Again, I'm probably in the minority here, but it's just an annoyance of mine when I use these the mobile clients. At any rate, so that would be my first thing that I would do. I would prefer a web-based stack of technologies over a native client technology if it's pure forms over data. Now, secondly, if I'm not a games developer, but if I were and I was building some graphic intensive application, or I needed to utilize some hardware like a webcam on the system, and I wanted to take advantage of being in an app store of some sort, like the Windows 8 App Store, then I would consider creating a native client application at that point. So on the Windows desktop platform, I'd be thinking about a Windows Presentation Foundation application, but I'm not a games developer. If I were, I'd be thinking about XNA or some third-party platform like Unity. Again, I'm not the kind of guy who gravitates automatically towards native client applications nowadays, so it would have to be really compelling for me to go in this direction. The third thing that I would say is that there's one more scenario that may require a native client application. If I had a security requirement that couldn't possibly be implemented in a web browser, perhaps I needed to lock down the functionality or I needed to secure the data transmission somehow, then I'd be forced to choose Windows Presentation Foundation, even for a forms over data style application. So you can see that from my perspective, at the time I'm recording this video, there's only 2 presentation technologies that I would even consider for greenfield development. Greenfield is the term for building something new from scratch. Sure, if I'm maintaining an existing application, I'm going to have to use whatever the original developers chose. But if I'm not, then I'm really looking at ASP.NET MVC or I'm looking at WPF. All right. And yeah, I would consider using ASP.NET Web Forms Dynamic Data, which allows you to build a CRUD style application quickly and easily using templating within Visual Studio. Again, at this point, we're not interested in mitigating change. We're interested in quick development, slapping something together as fast as possible, allowing our tools and APIs to drive the development process, so a tools-driven development process. So yes, this is viable only if there are no real business rules, we have a short time frame, we set expectations within the organization, things of that nature. Otherwise, I'm back to thinking in terms of a layered architecture. All right, so let me explain why I'm bullish on a web stack of technologies, even inside an enterprise for an intranet application, and also why I'm bearish on native client development. First of all is the issue of deployment. In a web stack, a webmaster deploys updates to the system in an automated and deterministic way to a set of machines that the webmaster can control. Once the changes are deployed on the web server, they're instantly available to all users simultaneously. In a desktop environment, deployment is a tricky matter. It's not impossible that you can use a technology from Microsoft like OneClick or a .NET deployment technology like that can allow the application to update itself. However, it's a big timing issue. You have to be careful about versioning the database and those sorts of things, because updates may not happen in a small window of time. It could take days or weeks for everybody in the organization to update their desktop application to the latest version. The second thing I'd say is that the web stack is consumable across a wide range of operating systems and devices. Regardless of the operating system vendor, the browser vendor, or device, I can probably massage my app to work for that user. Furthermore, this bring your own device to work is a new trend in the IT world that encourages employees to bring their own devices. Heck, they're even encouraging this at my son's school. This saves organizations from having to purchase, maintain, and upgrade hardware and software for their employees. Employees can bring their own laptops and tablets and so forth, and as long as they can open a web browser, they can do their work. They can use low-cost subscription-based software for things like office-style applications, email, and collaboration. Now sure, companies lose the ability to control the user's experience or monitor their usage of the network resources. And there's definitely some challenges for governance and certain laws that require an audit trail for certain types of data. Obviously, this doesn't make sense in every scenario. However, for many companies that merely need to collaborate and they only need essential software, they can be delivered in a web browser. And so this is a really viable option nowadays. Third reason I prefer a web stack is that it's increasingly being leveraged for server-side development. So think, for example, Node.js, and even for desktop development. Think about the Windows App Store apps that you can build using HTML5, CSS3, and JavaScript. And I'm willing to bet that it's just a matter of time before we see a desktop equivalent in the .NET world where you can write JavaScript, HTML, and have it compiled to be a client application on the desktop. If you can leverage your web development knowledge in all these ways, doesn't it make more sense to invest your time, or if you're a business, invest in training your developers to utilize a highly leverageable technology rather than a single-use technology like XAML? So if you take a look at the guide and you read the chapter that we just referred to, I guess it's chapter number 6 on the presentation layer guidelines, it references rich internet applications. It's specifically talking about Silverlight. Here's a great example of a technology that lived a short life and why it's unwise to architect around a presentation layer and or a deployment strategy. The Silverlight project template still exists in Visual Studio 2012. I hear that they're working on another version of Silverlight version 6. At least that's the rumor at the time I'm recording this, but it's essentially a dead technology. The development team, for the most part, is gone and they moved on to other companies or other projects within Microsoft. At one point, they attempted to position Silverlight as a media tool, and then at another point, they attempted to position it as a line of business tool, and even dedicated a product, LightSwitch, to building line of business style applications, rich client applications. Now, while that tool is still available, it seems like they're moving forward with LightSwitch, but I just visited their website. They're trying to migrate users to the new HTML5 JavaScript model for line of business applications. So I would just say that be forewarned of the possibility that the investments that you make in a given presentation technology might be wasted in the future. So minimize that risk by keeping your client, or rather your presentation layer, as thin as possible. Delegate presentation responsibilities only and keep all business logic tucked away safely in its own layer, ready for new presentation layers to be implemented and used in the future. With regards to native client development, specifically what I would call native client development that's intended to be distributed in an app store. So today that would include the Windows Phone, the Windows 8, and so forth. Heck, it's true for iOS and Android as well. When you hear App Store, think consumer focus. If you're building applications for the enterprise, I doubt that there will be much of demand for building Windows Phone or Windows App Store apps. Sure, occasionally some enterprising evangelist at Microsoft attempts to shoehorn the presentation technologies into the context of an enterprise scenario. But that's Microsoft's marketing machine trying to fit a square peg in a round hole. So yeah, you're going to see articles of how you can sideload a Windows 8 application onto a Surface device for use within the enterprise. I think that's an edge case scenario. I don't think you're going to see that a lot unless something changes dramatically after I record this video. And sure, your mid to large size organization may want to pursue this as some sort of an experiment. Perhaps you can find a niche in the marketing department as a tool to reach new customers or for branding purposes or something like that. But this generally falls outside of the realm where I see most .NET related jobs available today. Most .NET related jobs involve building enterprise scale applications for mid to large size organizations. That might be a gross overgeneralization, even reductionist attitude towards .NET, where it fits in today's IT world, but I see that to be the case. So if you're focusing on consumer or small business, honestly, you're most likely a 1 to 5 person startup. Startups are generally not choosing .NET. They're choosing Ruby on Rails or Node.js on the server side, and then HTML5, CSS3, JavaScript, jQuery, and a host of JavaScript libraries on the client side. And if they're focusing on native client development at all, they're focusing on iOS or Android. Now maybe that'll change in the future, but as I record this video, Microsoft, honestly, they've lost their consumer focus and their latest offerings are struggling for relevancy. I would let that scare you. I wouldn't let that scare you away from the platform completely. In my opinion, there's just more stable jobs in the enterprise.NET world than in the startup space. And please, verify that for yourself. You can argue with me all you like, but that's my opinion, and it's free. All right, so having said all of that, I'm seeing an increasing number of jobs that want to see some background with native client development, particularly iOS, in addition to .NET. I'm thinking we're going to see this more and more, but that's a tricky skill set to find, I would think. So again, in my opinion, there's really only two .NET presentation technologies to choose from to create the presentation layer in an enterprise-scaled and scoped application. You've got ASP.NET MVC, which would include a host of other technologies that I refer to as the web stack. And for the desktop, you would choose Windows Presentation Foundation. Now, there are design patterns for usage-specific usage of each of these. I've used the term design pattern a couple of times up to this point already. Think of a design pattern as a good solution for a common problem, and it can be given a name so that we can have a conversation using these key terms that are loaded with all of this design in the back of our mind, these huge concepts in the backs of our mind as we talk about them. So for example, ASP.NET MVC uses Model View Controller. That's what MVC stands for. It's a design pattern, which some have suggested is actually a bit of a misnomer. It's probably the way that it's implemented in ASP.NET MVC, closer to a pattern, which is a cousin of MVC called Model View Presenter. This design pattern is baked into the framework, and while you can circumvent it, you really have to work at it. This is one of the strengths of the ASP.NET MVC framework, that it provides a clear pattern, an obvious path to follow to design your presentation layer. Still, many have misunderstood the role of ASP.NET MVC and have attempted to use it to handle all of the concerns, putting business logic and data access in the same project, or in some cases, even in the same action methods. And clearly, this is a no-no if we intend on designing our applications to be resilient to change, right? Now, the Windows Presentation Foundation developers often utilize another pattern. It's called MVVM, or rather, Model View View Model. Essentially, the user interface components on the view, so things like text boxes, combo boxes, grids, and so on, they bind to a view model that contains data. Those user interface components are aware of any changes to the underlying data due to some change in the model, or rather, the presentation logic as it interacts with the domain layer. The changes are two ways, meaning that developers can write code to handle the event where the user edits data in the view model via the user interface controls in the view. The changes can be sent to the appropriate methods in the domain layer to validate, perform business logic, and potentially persist that data via the data access layer or the persistence layer. MVVM would require a mini series on its own, so it's just something else we're going to add to the to-do list at this point. The key idea in this lesson was twofold, or actually threefold. First of all, to honor the separation between the presentation concerns and the business logic concerns. Secondly, to honor the separation of sub-concerns surrounding presentation, namely concerns related to working with the business logic layer or the domain layer, the concern related to the presentation data, or rather the view model, and the concern of the presentation itself. And then third, the mapping of specific .NET technologies to the two primary presentation styles, web and native client. All right, so in the next lesson, I'm going to tackle the persistence layer. We'll see you there. Thank you.